Jonathan. I want to talk about functions and asymptotes today, and this is for my integrated 3 math class, but it's applicable in just about every math class. So we go back a few years. I mean, it all starts with the number line. The number line is really your x-axis. From one dimensional space, you add a second dimensional space, and now you have a Cartesian coordinate plane with x and y. You go to an ordered pair, say over 3 up 1. Just kind of going through all your years of math, and then from there you go to linear functions or linear models. So let's say I have a straight line like that. Let's say that's y equals, actually pretty flat line. Let's say that's y equals 1/2 x plus 1. Remembering this is my y-intercept, this is my slope. So from 1 I rise 1, run 2. Like that. So let's say I rise 1, run 2. And that's a graph or an equation. And then really from that, to turn that into a model, is really just applying that. Let's say that's the growth of business over time. So let's say that's sales of a business over time. So rather than say y equals 1/2 x, I'm just going to call it a function and replace y with f of x. So f of x equals 1/2 x plus 1. And let's say that's thousands of dollars over time. So I know at time equals 2. So 2 months in there. I take 2, plug it in here. 1 plus 1 is 2. So I'm able to use that as a model to make predictions. That's really the power of functions. Okay? So f of x really just replaces y, and it calls it a function. It's kind of a machine where you have an input. Your x is your input, and your y is your output. So here my input is 2, my output was also 2. Okay? My input was 6. I take 6, plug it in here, get 3. 6 times 1/2, 3, plus 1, and my output would be 4. Okay. The definition of a function is that there is only one corresponding dependent variable for any given independent variable. So if my x is 3, there's only one corresponding value, 2.5. So the way I check to see if it's a function or not is with the vertical line test. I draw a vertical line anywhere in my graph, and it can only cross my graph in one place, then yes, it is a function. If on the other hand my graph looked like this, like y and x, and I was to look at a given x value here, say x is equal to 3, I don't know what my y value is because it could be this value of say 2 or this value of 4. So this is not a function because in fact for any x value there are 2 corresponding y values. So the vertical line test shows you it is a function. If it crosses in more than one place, it is not a function. Okay? So that's really the definition of a function. Really useful. I've used them in my life. A lot of different applications, business, sales, river flow, temperature. I really like kayaking. You know, here's a model, a function that shows river flow over time. It looks like that at the peak. This is a snowmelt river, right? This would be time, this would be river flow. It melts the most amount of snow, and then in the middle of the night, the least amount of snow, and decreasing over time. So these functions are really powerful because they're models that allow you to make predictions. Okay? So then let's take a look at asymptotes. And really what's going to happen with an asymptote is we're going to have a fraction. So now my model or my function is f of x is equal to 1 over x. Okay, so here's my Cartesian coordinate plane. Here's x, here's y. Okay. So I really want to set up a t-bar with a lot of values in it. So here's x and y. I don't know how to graph something, so I just pick any value and plug it in. So when x is 0, 1 divided by 0 we know is undefined. So it's undefined there. So that's what an asymptote is values that it cannot be. So when x equals 0, I have no corresponding values. So the way I like to draw this, or think of it, is a fence. And actually, I like to think of it as an electric fence. So there's my asymptote. It's dotted to say it can't ever be that. I could get close to it. I could actually get infinitely close to it, but I can't actually touch it. Okay. Here's another thought too. So that's a vertical asymptote where x equals 0, because those are values I cannot have. But how is y, or f of x, going to be 0? It can't, right? The only way this can be equal to 0 is if the numerator is equal to 0, and the numerator is a number 1. So y can't be 0 either, so that's going to give me a horizontal asymptote. I can't have any values of y that are equal to 0. Now I want to figure out what my graph looks like. So I'll just start picking values. When x is 1, plug 1 in here. 1 divided by 1 is 1. When x is 2, I'm getting low on the board there. 1 over 2 is a half. When x is 3, 1/3. When x is 4, 1/4. When x is 100, 1/100th. So I can see I have the point 1, 1. But as I get larger and larger in x, my denominator gets larger and larger, so my whole thing gets smaller and smaller. So it starts to come down this way. It approaches that asymptote, but never touches it. This is really a big idea, possibly the foundation of calculus, limits. But let's see what happens between 0 and 1. If I pick a half, 1 divided by a half, 1 divided by a half is the same thing as 1 times the reciprocal is 2. So at a half, I'm up 2. At a quarter, 1 divided by a quarter is 4. At an eighth, 1 divided by an eighth is 8. 1 divided by 1/1,000,000th is a million. 1 divided by 100,000,000th is 100 million. So I can see as I get closer and closer to 0, right, on x, as I get closer and closer to 0 in x, I get closer and closer to a really big number in y. I can't ever actually get to 0, just like I can't actually ever get to infinity. But that's the big idea there. As I get closer to 0, I get closer to infinity. Then if I want to find other values, I just pick negative values, and I can see all of the negative values will be the same. 1 divided by -1 will be -1, and I can see my graph will be down here in the third quadrant. So it'll be line of symmetry at x equals -y. So it's a reflection over that line. My asymptote, my horizontal asymptote is y equals 0. My vertical asymptote is x equals 0. These lines get ever closer, but never actually get there. So as x approaches infinity in this direction, y approaches 0. As x approaches 0 in this direction, y approaches infinity. It's a big idea, but it's really building on all of the math you've done for years. Okay? The last couple pieces is really domain and range. So let me go back to that sales model. Right? So if I'm talking about a sales model or a function, let's say f of x is equal to 3x. And this is how many thousands of dollars I sell at my business. And this is at time. Right? It might look like that. I have that error to say it's infinite, but that's a little bit of an exaggeration. And I have actual values I can place in here, right? I can't go back in time. I can't have negative time. So my domain, the possible values of x, is x is greater than or equal to 0. And my range, which is possible values of y, move that over a little bit, which is my possible values of y. So my range, I can't have negative sales. I mean, I can have negative profit, but I can't have negative sales. So my range, possible values of y, so y is greater than or equal to 0. Okay, so domain, possible values of x, range, possible values of y. So that's an application. Let's say my linear function of sales over time looks like that. My domain is positive values of x, positive values of y. Let's say I sell ice cream, right? That function might actually look like this. And again, it's seasonal, right? I probably sell a lot of ice cream in the middle of summer, not very much ice cream in the middle of winter. The next summer I sell a lot of ice cream, next winter not very much. So, if this is a model of your ice cream business, you probably want to introduce another product like coffees or something that you'll sell in winter. And that model might look like this. A lot of sales in the middle of winter, not very many sales in the middle of summer. And then those two products will balance out to give you, more consistent sales over time. So that's an application of domain and range and functions. And in this case, where we're looking at this function, its domain is all real numbers. However, x cannot equal 0, because that will give me a non-real solution. And my range is y cannot equal 0, because that will give me a non-real solution. So that's an overview of functions, domain, range, and asymptotes, horizontal and vertical asymptotes. Think of that asymptote as an electric fence that the function can approach but never get to. It takes a little while to think about this, but it's a cool idea, and it's really applicable in a lot of different models. Okay, hit the subscribe button, and we'll talk to you later.